Hello friends, welcome to my lecture on methods for finding particular integral for higher order linear differential equations with constant coefficients. We shall begin with a non-homogeneous linear differential equation which can be expressed as a naught x into nth derivative of y with respect to x plus a1 x and minus 1th derivative of y with respect to x, then an minus 1 x, then dy by dx by 1 x means dy by dx plus an x by x equal to rx, where a naught x is not equal to 0. So, this is nth order linear differential equation which is non-homogeneous. We shall be finding general solution of this assuming that the coefficients of the derivatives a naught x, a1 x, an minus 1 x and then an x, they are constants. So, we shall see how to find the general solution of equation 1 when the general solution of the corresponding homogeneous equation is known. So, we have in our previous lecture we have seen how to find the general solution of the homogeneous nth order linear differential equation. So, we shall see that once we know the general solution of the nth order homogeneous linear equation, then how to find the general solution of the nth order arbitrary non-homogeneous linear differential equation. So, let us see what we do is we have the following result. We actually did this result for the case of n equal to 2 second order linear differential equation with constant coefficients. Now, we are doing it for nth order differential equation. It is that result can easily be generalized. So, we have this theorem is actually generalization of that result. So, if y1 x, y2 x, yn x is a basis means it is a fundamental set of solutions of equation of the homogeneous equation associated with the equation 1, this one, equation 1, this one, this is equation 1. So, y1 x, y2 x and so on yn x are actually n independent solutions of the homogeneous equation here. So, they form a fundamental set, and fundamental set is also called as a basis of solutions. So, let y1 x, y2 x and so on yn x be a basis, and c1 y1 plus c2 y2 and cn yn x is the general solution of the corresponding homogeneous linear equation Ly equal to 0. Then if by px is any particular solution of the non-homogeneous equation 1, the general solution of equation 1 can be expressed as sum of the general solution of the associated homogeneous linear equation, that is c1 by 1 plus c2 by 2 and so on cn by n plus by px. So, this is the result. Let us see how we prove it. The proof is very simple. So, since by px is a particular solution of equation 1, it will satisfy equation 1. So, L by px will be equal to a naught by p n x, a1 by p n minus 1 x and so on a n minus 1 by p 1 x plus a n by p x equal to r x. Now, let us subtract this equation 3 from equation 1. So, when you subtract this equation 3 from equation 1, what we will get is the following. We will have a naught. So, these a naughts a1, a2, an minus 1, an, they are now constants, they are no longer functions of x. So, a naught by n x minus by n minus by p n x plus a1 by n minus 1 x minus by p n minus 1 x, an minus 1 by 1 x, ap by 1 x, an by n x by x minus by p x equal to 0. Let us denote by x minus by p x by z. So, if we do that, what we will get is a naught zn plus a1 zn minus 1 an minus 1 z1 plus an z equal to 0, but this equation is the corresponding homogeneous equation of 1 whose basis is by 1 x, by 2 x and so on by n x. So, the general solution of equation 5 is z equal to c1 by 1 plus c2 by 2 and so on cn by n. Now, z is equal to by x minus by px. Okay, so, we shall have by x minus by px equal to this quantity c1 by 1 plus c2 by 2 and so on cn by n, and therefore, by x equal to c1 by 1 plus c2 by 2 cn by n plus by px. Now, this solution contains an arbitrary constants, so it must be the general solution of equation 1. So, this is the proof. Let us now look do some examples on this. So, first example we will do is a linear differential equation of third order with constant coefficient. So, by triple prime minus 6 by double prime plus 12y dash minus 8y equals 12 e to the power 2x plus 27 e to the power minus x. Let us first write the general solution of the associated homogeneous linear equation. So, associated homogeneous equation is by triple prime minus 6 by prime plus 12 by prime 6 by double prime minus 12 by plus 12 by prime minus 8y equal to 0. So, this is the associated homogeneous linear differential equation of third order. In order to solve this equation, we write the corresponding auxiliary equation. The auxiliary equation is m cube minus 6 m square plus 12 m minus 8 equal to 0. Now, we can notice that this is a cubic equation in m. So, we shall have to find a value of m which satisfies this equation. Obviously, m equal to 1 does not satisfy, but m equal to 2 satisfies this equation. Since m equal to 2 satisfies this equation, m minus 2 is a factor of the cubic polynomial in M. So, we will have m minus 2, this is a factor of this equation m minus 2, and then we have m minus m square minus 4m plus 4. We can easily check this, that the other factor is m square minus 4m plus 4, and this gives you m minus 2 whole cube equal to 0. So, we have m equal to, so the value of m that is 2 occurs thrice. Okay. So, it is a case of repeated roots, and therefore, the general solution of the equation 2, this is equation 2, or rather I would write it as equation 1. General solution of equation 1 is y equal to C1 plus C2x plus C3 x square e to the power 2x. Now, we shall find a particular solution of the given equation. So, we now find a particular solution by Px of the given equation. Okay. So, by Px we know by Px is nothing but the particular integral Pi, and this is equal to 1 over d cube minus 6 d square plus 12 d minus 8 operating on 12 e to the power 2x plus 27 e to the power minus x. Okay. Now, this is equal to 1 over d minus 2 whole cube, okay, 12 e to the power 2x plus 27 1 over d minus 2 whole cube operating on e to the power minus x. Now, let us apply the formula. We know that 1 over fd e to the power ax is equal to 1 over fa e to the power ax if fa is non-zero, and when fa becomes 0 we apply the formula 1 over fd e to the power ax into b, where b is any function of x, as 1 over equal to e to the power ax 1 over f d plus a operating on b. So, we apply this formula. Now, here we see that this 12 is a constant. When we replace d by 2 here, okay, d minus 2 becomes 0. So, we shall apply the formula 1 over f d e to the power ax into b equal to e to the power ax 1 over f d plus a b. So, this is e to the power 2x 1 over d plus 2 minus 2. So, we have d cube operating on 1, and here we shall have 27, d will be replaced by minus 1. So, we will have minus 3 to the power 3. Okay. Now, here 1 d represents d over dx. So, 1 over d represents integral with respect to x. So, we have to integrate 1 thrice with respect to x. So, once when we integrate it once we get x, when we integrate it again we get x square by 2, and when we integrate it again we get x cube by 6. So, 12 e to the power 2x x cube by 6, and here we have this is e to the power minus x we have to write. So, this we have minus 20, this is minus 27. So, minus e to the power minus x we have. So, this is 2x cube e to the power 2x minus e to the power minus x, and thus the general solution is y equal to solution of the homogeneous equation, that is C1 plus C2x plus C3x square e to the power 2x plus by px, which is 2x cube e to the power 2x minus e to the power minus x. So, this is the general solution of the equation given in example 1. Okay. Now, let us see how we will solve equation 2. So, let us look at equation 3, example 2. This is y triple dash minus 2y double dash plus 4y dash minus 8y equal to 8 times x square plus cos 2x. Okay. So, we will again find the general solution of the associated homogeneous linear differential equation. So, associated homogeneous equation is y triple prime minus 2y double dash plus 4y dash minus 8y equal to 0. Now, in order to find the general solution of this, we write the corresponding auxiliary equation. The corresponding auxiliary equation is m cube minus 2m square plus 4m minus 8 equal to 0. Now, it is easy to solve because we see that its factors are m minus 2 into m square plus 4 equal to 0. So, we get m equal to 2 and plus minus 2i. So, one root is real which is 2, and the other two roots are complex conjugate they are 2i and minus 2i. So the general solution is of the equation 1. Corresponding to the here alpha is equal to 0, beta is equal to 2. So we have e to the power alpha x, that is e to the power 0 x, that is 1. So we have C2 cos 2x plus C3 sin 2x. This is the general solution of the associated homogeneous equation, or you can say this is the complementary function of the given equation. Now let us find the particular integral, a particular solution of the given equation is ypx equal to pi particular integral, which is 1 over d cube minus 2d square plus 4d minus 8, okay, operating on 8 x square plus cos 2x. Okay, so I can write it as 8 times 1 over d cube minus 2d square plus 4d minus 8 operating on x square plus 1 over d cube minus 2d square plus 4d minus 8 operating on 8 cos 2x. So 8 I can write outside. Okay, so now here fd is d cube minus 2d square plus 4d minus 8. 1 over fd we have to expand in descending powers of d. So we will write 8 times minus 1 over 8, and then we write 1 minus 4d by 8. 4d by 8 we shall write as minus 4d by 8, so 1 by 2d, and 9 minus 1 by 4 d square, and then d cube by 8 raised to the power minus 1 operating on x square. So what we do is we have to write it in the ascending powers of d. So we write 1 over minus 8 outside, so that we have this expression 1 minus this quantity divided by 8. So 1 by 2d minus 1 by 4 2 by 4, yeah, 1 by 4 d square plus d cube by 8. Okay, and here what we do is we replace d square by minus a square. Okay, so minus 4. So that means here we have d square into d square is replaced by minus 2 square, so minus 4. So minus 4d d square by minus a square, that is minus 4. So we have plus 8, and here we have 4d minus 8. Okay, so this becomes 0. So this becomes 0. So what we do is we factorize it as okay, these factors are d minus 2 d square plus 4. Okay, so d minus 2 d square plus 4 cos 2x. Okay, because of this factor d square plus 4, okay, when we replace d square by minus 4, it is becoming 0. So what we do is we operate by d plus 2 and 1 over d plus 2 in the numerator and denominator. So we operate by that. So okay, so let me write it separately. Okay, so let us find the expression for this first. So 1 minus 1 by 2d minus 1 by 4d square plus d cube by 8 raised to the power minus 1 x square. So, this let us expand. So, we get 1 plus 1 by 2d minus 1 by 4d square plus d cube by 8 plus x square. 1 minus, when we express 1 minus x to the power minus 1, we get 1 plus x square. So, we get 1 by 2d minus 1 by 4d square plus d cube by 8 raised to the power 2 and so on. This operating on x square. Okay. So, this will give you x square 1 by 2d of x square. D of x square is 2x. So, 2x by 2. So, we get x here. We get x here, and then 1 by 4 d square of x square is 2. So, minus 2 by 4. So, we get minus half. D cube of x square is 0. So, we get 0. So, we get 1 by 2 d of x square, that is 1 by, okay. So, this is 1 by 4. When we square this, 1 by 4 d square of x square is 2. So, 2 by 4. So, we get 1 by 2. The other terms contain powers of d higher than 2. Okay. So, they will give you 0. So, we will just get this. So, this will cancel with this, we get x square plus x. Okay. So, now let us find out 1 over d minus 2 into d square plus 4 cos 2x. Okay. Let us recall that. Okay. So, what we will do is we operate by d plus 2 and 1 over d plus 2. D plus 2 and 1 over d plus 2 are inverse operators. So, their total effect is nil. So, this 1 over d minus 2 and then d square plus 4. Okay. Now, this is how much? This is d plus 2. I think I will reshuffle this, d square plus 4 and then d square minus 4 cos 2x. Okay. Now, d square, if in this factor d square is replaced by minus a square, we get minus 4 minus 8. So, minus 1 by 8 d plus 2 over d square plus 4 cos 2x. Now, let us recall that 1 over d square plus a square sin ax is equal to minus x by 2a cos ax and 1 over d square plus a square cos ax is equal to x by 2a sin ax. So, what we will get? 1 over d square plus 4 cos 2x will be x by 4 sin 2x. So, minus 1 by 8 d plus 2 and we shall get x by 4 x by 2a equal to 2. So, x by 4 sin 2x. Okay. Now, what we will do? So, this is equal to minus 1 by 32 d plus 2 operating on x sin 2x. Okay. So, this is equal to minus 1 by 32 d of x sin 2x. When you d means d over dx operating on x sin 2x will give you sin 2x plus 2x cos 2x and then we will get 2x sin 2x, 2x sin 2x. Okay, so let us add this let us put these values there. What we will get is, thus by px is equal to, by px is equal to 8 multiplied by minus 1 by 8 is minus 1. So, we get minus x square plus x, and then 8 times minus 1 by 32. So, minus 1 by 4, minus 1 by 4, and then we have 2x times sin 2x plus cos 2x. Okay. Then we have 8 times minus 1 by 32, so minus 1 by 4 sin 2x. Now, when we add this by px to the general solution of the homogeneous equation, the general solution of the homogeneous equation is C1 e to the power 2x plus C2 cos 2x plus C3 sin 2x, then minus 1 by 4 sin 2x will get absorbed in this part of the general solution of 1 C3 sin 2x. So, we shall not consider this, and therefore, we shall write the general solution of equation 1 as, so the general solution of the given equation is by equal to C1 e to the power 2x plus C2 cos 2x plus C3 sin 2x. C3 will be actually C3 minus 1 by 4, we can write it as C3 minus 1 by 4 sin 2x, and then we have minus x square plus x minus 1 by 2 into x sin 2x plus cos 2x. So, C3 minus 1 by 4 can be replaced by a new arbitrary constant, and we write C1 e to the power 2x plus C2 cos 2x plus, say suppose some other constant we can write C4 okay, sin 2x, and then we can combine this whole thing and write minus 1 by 2 times 2x square plus x, and then we can write plus x times sin 2x plus cos 2x. So, this is the general solution of the equation given in example 2. Now, a problem given in example 3 is a bit different one. So, let us try that one also. Let us see how we solve that third question. So, in third question is by 4, fourth derivative of y with respect to x, tan y double dash plus 9y is equal to 96 sin 2x cos x. So, here the associated homogeneous equation is by 4 plus tan y double dash plus 9y equal to 0. Let us write the corresponding characteristic equation, or you can say auxiliary equation, they are same things. So, the corresponding characteristic equation is m4 plus tan m square plus 9 equal to 0. Now it can be solved easily. The factors are m square plus 9 into m square plus 1. You can take m square equal to t, then it becomes a second degree quadratic equation in t, and you can solve it. So, replace t by m square, you get this. Now, m is equal to plus minus I plus minus 3 are its roots. So, the general solution of the equation 1 is y equal to C1 cos x plus C2 sin x plus C3 cos 3x plus C4 sin 3x. Okay. Let us now find particular integral, or you can say a particular solution of the given equation. One over d4 plus 10d square plus 9, okay, operating on 96 sin 2x cos x. Okay. Now, the formulas that we have studied, okay, none of those formulas can be applied to get the particular integral here, because the formulas that we have done is that 1 over fd operating on sin ax, 1 over fd operating on cos ax, those formulas. So, here what you do is we write it as 48 times 1 over d4 plus 10d square plus 9. Okay. Now, 2 times sin 2x cos x can be written as sin 3x plus sin x. Sin c plus sin d is twice sin c plus d by 2 into cos c minus d by 2. Okay. So, we have this, and this then can be written as okay. So, 48 times, let us apply this operator 1 over d4 plus 10 d square plus 9 on each of the terms here. So, we will write it as factors. Let us write 1 over d square plus 1 d square plus 9 operating on sin 3x, 1 over d square plus 1 d square plus 9 operating on sin x. So, this is equal to 48. Now, 1 over d square plus 9 cannot be operated on sin 3x, because d square plus 9 becomes 0 when d square is replaced by minus 3 square. So, 1 over d square plus 1 is operated on sin 3x. So, 1 over d square plus 9, this d square is replaced by minus 9. So, we get minus 8 here, and we get sin 3x, and then we have 1 over d square plus 9 is operated on sin x first. So, d square is replaced by minus 1 square. So, we get 1 over d square plus 1 into 8 sin x. So, this is equal to 6 times 1 over minus 1 over d square plus 9 sin 3x plus 1 over d square plus 1 operating on sin x. Now, let us recall that 1 over d square plus a square sin ax is minus x by 2a cos ax. So, this is equal to 6 times minus into minus x by 6, because a is 3 here, cos 3x, and here we get minus x by 2 cos x. So, this is x cos 3x minus 3x cos x, and thus the general solution is y equal to C1 cos x, C2 sin x, C3 cos 3x, C4 sin 3x plus x cos 3x minus 3x cos x. So, this is the solution of the general solution of the equation given in example 3. With that I will like to conclude my lecture. In my next lecture we will discuss about the partial differential equations. Thank you for your attention.